Hello everybody. My name is Ezutah Olugu, doctor. So I'll be talking about turning of Inconel 718 using nanoparticle based vegetable oil. So this study actually is an ongoing study which we have already done part of it earlier. So we are looking at using vegetable oils as an alternative to conventional lubricants in cutting operations. So we know conventional lubricants actually they have problems such as being toxic and also their pollutants. They have serious environmental issues and health issues for operators. So because of these things and also disposing them causes a lot of problem with water pollution and also soil pollution. Hence, there's a need to come up with better cutting fluid that will be sustainable and more economical. So in that light, we have actually chosen to use few vegetable oils and try to cut Inconel 718 using a carbide insert. So these are some of the vegetable oils we decided to use for this study: coconut oil, palm oil, and also on the other side, we are using aluminum oxide nanoparticles to be the additive. So during the cutting operation, this was done actually using a lathe machine. So the lathe machine, we cut the lathe machine. Actually, we applied the Taguchi method of design of experiment to actually reduce the number of runnings we are going to conduct. So in that case, we were able to come up with the Taguchi orthogonal arrays, which gave us this 9 by 9. So 3 by 3, so 3 by 3. So which means the palm oil with at the rate of cutting speed of 108 and also 140 and 215. The same thing, we have coconut oil and the olive oil. So with this orthogonal array we have, we were able to run the experiment. So from the experiment, you can see the main parameters which were measured, which includes the temperature, and also we used the signal to noise ratio on Minitab to actually come up with the lower the better. So in that case, we can see the temperatures that were obtained from the reaction from the cutting experiments. So it can be seen from these that the palm oil actually did better than most of the other oils. And if you also look at the signal to noise ratio, you can also find out that it also performed better in that same respect. Then if you look at this graph, you can see from the graph where we have the main effect plot for the signal noise ratios for the different cutting oils and also for the different cutting parameters. So we can see here that the palm oil actually did quite well in terms of all the areas. In fact, if you look at the cutting speed, you can see that the cutting speed actually yielded a very good result with the palm oil and also all these other parameters. Then these are some of the tool wears, because we also use the tool wear as part of the output we use in measuring the effectiveness of the oil. So you can see here that we have that the palm oil gave a tool wear of about 0.8645425 mm, while coconut oil with aluminum oxide nanoparticle gave 1.335 mm, and all the olive oil had the highest tool wear, which is 1.4079 mm. Then in terms of the chip morphology, so in the terms of the chip morphology, we used the Z equal to A2 over A1. So that was the formula we used. In this case, you can see that we have the uncut chip thickness and the cut chip thickness in this case. So when you have the ratio, so we were able to get the Z values. So the Z values, we can see that from the Z values, we have that the Z value coming out from the palm oil actually gave one of the lowest at 1.35 and 1.105. Then we also have from the coconut oil, we have at 1.215. So if you look at the signal to noise ratio, which was also obtained from the Minitab, we can see that it actually had the lowest At this point, we have the lowest from the coconut oil. So this is the plotting from the main effects plot for the signal to noise ratio, which actually symbolizes what we have from the chart in the table. So you can see from this chart actually that in terms of the chip morphology, that the coconut oil actually did quite well, and also the olive oil did reasonably well also when we have a very low depth of cut. So then the other side, we also look at the other things. So in conclusion, actually, for this small short video is just to say that after we use the aluminum oxide to enhance the effectiveness of the cutting fluid, vegetable oil cutting fluid, and we actually applied the Taguchi L9 orthogonal array to reduce the number of experiments that were conducted, it was found that the palm oil actually with aluminum oxide did best in terms of cutting of Inconel 718. So this is actually what we have found from this study. So we're also proposing that further studies should be conducted by using other nanoparticles to actually look at all the mix as an admixture to all this oil to see how the effectiveness will be in terms of all these cutting operation. We're also suggesting that more testing should be conducted on the workpiece material. So thank you very much. So any questions can be directed to me through email or other means. Thank you.